Before I begin, I just saw this news come up that former President Jimmy Carter, 100 years old, 100. Rare for people to hit that century mark, but he did, and he passed away today. So take that for what it is. You know, you may have your opinions on him, good, bad, or indifferent. I actually really don't remember much of him as a president. Ironically, the one thing I did remember about him when I was growing up, when he took office, was in '76. I was 5 years old. I mean, I just barely knew about a president in an abstract way, and I think I remember hearing something about Billy Beer because of his brother. That was it. I mean, I really didn't understand the was it the Iran the issue with trying to get the the prisoners out, stuff like that. And yeah, I do know that after his presidency, he did do a lot with just like Habitat for Humanity and other things like that. So another president no longer with us. With that, I'm going to move on and go to advent of code. So let me just check one thing here. Okay, let's get some music going, as you do. And I did not look at day 11. Like I said, I didn't want to get ahead of myself, so did not look at 11. Let's look at it now. Plutonian, not plutonium. That would be a little dangerous. Plutonian pebbles. The ancient civilization on Pluto was known for its ability to manipulate space-time, because reasons. And while the historians explore the infinite corridors... Oh, wait, I gotta make sure that I got that up there. Okay. And while the historians explore their infinite corridors, you notice a strange set of physics-defying stones. At first glance, they seem like normal stones. They're arranged in a perfectly straight line, and each stone has a number engraved on it. The strange part is that every time you blink, the stones change. So don't blink. Just like that. You just don't blink. Sometimes a number engraved on a stone changes. Other times the stone might split in two, causing all the other stones to shift over a bit to make room in their perfectly straight line. As you observe them for a while, you find that the stones have a consistent behavior. Every time you blink, the stones either simultaneously change according to the first applicable rule in this list. If the stone is engraved with the number 0, it is replaced by a stone engraved with number 1. If the stone is engraved with a number that has an even number of digits, it is replaced by 2 stones. The left half of the digits are engraved on the new left stone, and the right half of the digits are engraved on the new right stone. The new numbers don't keep extra leading zeros. 1,000 would become stones 10 and 0. Makes sense. Okay. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number multiplied by 2024 is engraved on the new stone. So it has an odd number of digits. You multiply it. So big integer, hello. I can tell this is going to go wildly big. Unless we use some modding. So, unless we use some modding. No matter how the stones change, their order is preserved, and they stay on their perfectly straight line. Oh, it splits because of the even number. Okay. How will the stones evolve if you keep blinking at them? You take a note of the number engraved on each stone in the line. If you have an arrangement of 5 stones engraved with the numbers 0, 1, 10, 99, 999, you blink once, the stones trans. 0 becomes 1. 1 becomes 10 splits into 1 and 0. 4 becomes a split of 2 9s. And 999 would be multiplied and becomes that number. So after blinking once, your 5 stones would become an arrangement of 7 stones engraved with a number this. Here's another initial arrangement. So after 125 and 17, you can just trust that it splits like that. And so you think it's going to go up, but I can kind of see where this may taper off a little bit. After blinking 6 times, you would have 22 stones. After blinking 25 times, you would have 55,000 stones. Consider the arrangement of stones in front of you. How many stones will you have after blinking 25 times? Oh, bite me. Okay. Let's see. Save as. This is day 11. Okay. And now let's get our day 11 stuff up here. Nope, not that one. Gotta be this one. Make that 11. We get rid of this using. Maybe this using. Make that 11. Yeah, that's just going to be a string input. We really don't care. We don't know how many stones are going to be there. We don't even know what this is going to be. But, well, we know it's going to be a string. We have no idea what we're going to do for part 2. We can get rid of find stone rating. That and that map position record. There. Okay. So in both cases, we're going to do the same thing. Of our total stone count, which is equal to input length, which is not return. We just want to shut up the... Why? Why do you switch what you're going to give me as a suggestion? Okay. So a stone just has a number on it. And we can have a list of stones. What I'm trying to figure out in my head is... Is there any way to get this to not go out of control? I don't see how. Now, it doesn't matter what order the stones are in. I know it says up here that it will preserve the order. I'm immediately concerned that this is going to just blow up, go wildly out of control here. Even after 25 times, like just the sheer size. Even if you look at the input, it doesn't look like much. There's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. But even with the tour, after blinking 6 times, after 25 times, you get, of course, this all depends on your input and what you get and how it's going to break out in the stones. I mean, if you did this just brute force, like the way it's stating, and assuming you had an arbitrary long integer, or not integer, a list, and you could put stones in there with numbers, and we're in all likely going to have to use big integers here. That could be a fair amount of space taken up, and that's what I'm worried about. But trying to do something where you say, hey, I know that like a 2 becomes a 448. Like each number I think has a cycle. this almost feels like it's not the Colots, but it feels a little bit like it, where a 7, like if you just had a 7, it would go to a 1 and a 7. And then it would go to a 2024 and this. And then it goes splits into that and that, and then splits into that and that. So it's like, it feels like this one here. This says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would split. This wouldn't. This would. And I don't know if you can automatically say that if you have to multiply it by 2024 that you're automatically going to get, like here, 999 does not automatically make like a even length digit. I mean, we can try it with what we're going to get, but I don't think it's going to, it's going to be pretty nice. All right, so here we're going to say var stones is a new list of big integers, where the list, well, actually what we could do is say input split on, it's by space. So we split, we select, can we say two, like, no, we want to say to list. But we have to say select, or we're going to say big integer parse, what that is. Culture, info, current culture. And then we say to list on that. Okay, so that gets us our initial set of stones. And now we need to say for var I is equal to 0, I is less than 25, I plus plus. And then we just return stones.count. Easy. It's easy in terms of what it's going to do. It's hard in terms of how big this is going to get. So we say var stone is equal to stones at I. Why would you put a space there? Why would it put a space there? No idea. So we say if, what are the rules again? If stone is equal to big integer 0, then we take stones at I and we set it to 1. No. I mean, yes, but no. That's the number of iterations. This again, why are you doing safe handles up here? What the hell? For var s is equal to stones.length count minus 1. Stone is s is greater than or equal to 0, s minus minus. We don't want to base it off of the I. That's incredibly wrong. Okay, so now we get the s. If it's a 0, we make it a 1. Easy. If it has an even number of digits, else if stone to string, well, now we need to do this. We need to be a little fancier. We need to see var stone value is equal to stone to string. Yes, fine. Just give me the number. If the length mod 2 is equal to 0, that means it's even. Okay. There's probably an easier, better, more efficient way of determining how many digits it has, but actually, I wonder. You can get the bit length, which isn't really that helpful. I'm just curious. Let's look this up. C# digits in big integer. Yeah, exactly what I just said. Or you could do the log. Yeah, that's right. I remember I was kind of like, there's got to be a way to do this. Though I have a arguably 50-50 chance of needing to split it anyway, right? Because I have to, if it's even, I've got to make 2 stones now. Else, what we can do here is we can say there's probably a way to do this still with a little bit more efficiency. Actually, hold on. C# digits in big integer. I want to keep this around because yeah, it's 3 times slower than the log solution. So let's make a note. $11. Like, I'm wondering if you could say divided by, if you get the number of digits, it's 3, you then raise 10 to the power of 3, which gives you 1,000. I'm sorry, if you get the digits, it's 6. I might talk myself into this. If you get the digits as 6, then to get the leftmost one, or the rightmost one, is you basically need your splitter value, and so that would be 10 to the 3. And then what you could do is say the rightmost one is your current value mod the splitter, and then the left part I think the left part would be just dividing that. So can you do a div rem on it? Stone value div rem. Nope. Oh, no, I want stone. Do they have an overload for big integer? I bet they don't. You bastards. That's fine. So let's actually use this. Our length is equal to or we could say stone digits is the floor of the log of the stone plus 1. Okay. Now, if this is mod 2, if that's actually 0, then we have an even. That's going to take a little bit more work. The easier case is to say that the stones at I, S, come on, the stones at S is equal to the current stone times 2024. So that's easy. This one's a var splitter. This is, can you do big integer POW? Yes, you can. We want to say 10 to the stone digit. Thank you. You did that right. And so now what we want to do is we want to push in, we want to change the value for what's going to be on the right, and then we want to insert at that index so that it pushes the right one over, it just so it keeps that order. I don't know if it really matters for part 1, but it might for part 2. So we want to say stones at S is equal to, oh, it does do. Oh, you got to do it on the big. Yeah. That is exactly what I want. Var X and Y. I forgot what it's called. Divrem. We want to take our current stone value and we want to divide it by the splitter. And what does this give us? The quotient and the remainder. And so we want to say the stones at S is currently equal to now the remainder, because that's the right side. Wait. Yeah, I think so. I believe because I believe. And then we want to say stones insert at our current S, the quotient. Because that will push it over. But remember, we're going through the array backwards. So it won't affect our S count. And that's all we need. And then we get the stones count. Simple. This could not possibly blow up in my face. This definitely can't overflow with memory or do something like that. Not possible. Let's comment out to part 2 for a second. The input in the well, we could say, oh, fine. We'll just, I was like, we have 2 test cases technically. You could say 411, part 2, part 1. We just say the input because we're automatically doing it. You're saying it's 55,312, right? It didn't take too long, but I'm worried. I'm very, very worried. In fact, I want to put some telemetry in here. Console write line. Current iteration. Just so we can see where we're at. There. This is not gonna end well. I know it's not. So 11, part 1. I want to say file, read all text. I'll comment that out for a second. Hold on to your butts. Oh. Oh, that's cute. It's during the parsing. Really? Did I give it the wrong file? Yes, no wonder. Well, we make it. You can tell it starts grinding, but we make it. Is that the answer? It's the right answer. Okay, what happens if you get to 50 blinks? Your computer blows up. You can't. You literally cannot move on. I wonder what the maximum value is. Let's print that out as just as a fun thing. Console maximum value would be stones.max. It ain't that bad. I mean, that's hundreds, that's 100,000, that's a million, that's a billion. So if I'm reading this right, it's the maximum value is almost 400 billion. We're nowhere near close to what the maximum value is of a long. So if I say here, I just want to compare these. Yeah, we're nowhere near close to what the maximum long could be. But, Okay, so we have it. Get part 1 of day 11 is complete. My son jokingly said, when are you going to start streaming something that's interesting again? And I'm like, bite me. I'm like, this is interesting to me, damn it. I do like that I went this route. I think this is definitely the right route to go. You know. So, what horrors await us with part 2? The story is sure taking a long time. To be fair, the infinite corridors are very large. How many stones would you have after blinking a total of 75 times? I told you. I told you. Did I not tell you? Just 75. You know, who knows? Come on. This is going to blow up in my face. 11. And then we go here, and let's comment this out, and let's just see when this causes my computer to die. Yeah, it can't even get past 20. Well, it does, but you can see you just keep increasing the size of the array or the list, and it just grows beyond. So we're going to have to find a way to optimize this, because I don't think we could get this finished in the age of the universe. Yeah, the problem is that also I bet we're doing a lot of reallocations with the list, which is not good. I could let this run just and see where we get. I have an idea. What if instead of, like, we get our initial list of stones, but we do each one individually? Because what one stone doesn't affect any of the other stones. And so at least that way we'll keep the size small. So what I'm thinking is, they're literally both the same, right? So we want to get private static big integer. We don't want to parse. Get stone count with a big integer seed. I don't care about your culture info. Int iterations. So that way we can so we're not going to do this. We're going to say var stones is a new list, a big integer based off of the seed. Okay. And then we do iterations, which, if I could spell iterations, that would be good. And so we just do this for the iterations. Okay. And now we can come back up here and we get our initial set of stones. That's fine. But now what we can do is we can say, var stone count is equal to 0, and we're going to return our stone count. Okay. And so now we're going to say for each var stone and stones, we're going to get stone count plus equals get stone count, with that stone being the seed, and we want to do 25 iterations here. Oh, stone count can return an int. It doesn't, we know it's not going to be. Okay. And then part 2 is the same thing except 75. And arguably what we could really do for generalization is we could say, here's your input, here's a number of iterations, and then we just have one method, but that's fine. I'm just following the pattern of code that I'm currently doing here. So if we look at our tests, that still passes, because that still gives us the same value. Okay, now does it tell us, you're a jerk. Part 2 doesn't tell you, even for this one, what it would be after 75 times. You stink. I'm kind of curious. Let's run this again and just see visually what this looks like. That is a hell of a lot faster. A hell of a lot faster. But you know what's happening here. We're going to get, that was the right value, right? 228. Yeah. But I think we might need to do this recursively. And so we're going to need to do something where we basically say, here's a seed. And then after like 5 iterations, split that up with each one of those being a seed, get their values. And if they go descend even farther, you need to get their values. Because the problem with this is, sure, we split that up to reduce the amount of work, but I don't think that's going to help us here. Like, we still run into this problem where we start getting, like, it starts chugging at 31, which is a little bit of progress, but it's not enough. And so we need to take the value and then say, like, after 25 iterations, take that input, get for each value another 25. And then for these, we could make this a generalized thing to say, like, maybe like our bound on when we do another split to go through each one individually. You know, would be something that's configurable so that we could do it maybe in chunks of 10 or chunks of 5. And just for the problem at hand, we know that we have iteration counts divisible by 5. So now how to do this. This is the start. Again, this is like one of the problems that I ran into before, where you have where I kind of know what I want to do. It's now making it happen is going to be the interesting thing. So So what I think I need to do is say, we don't do this. We basically control how many times we're going to do these in chunks of 5. And so what I want is something like for var x is equal to 0, x is less than iterations divided by 5, x plus plus. And I can't spell. Okay. And then what I want to do is I want to say and again, I'm going to not make this generalized because I know it's either 25 or 75. So I can work with this. What I want to do now is grab this for loop, put it in here. And I want to say that the number of iterations I'm going to do is always 5. Except what I want to do is so this, the first time we do this here, that would give us what the iteration is after 5. And then what we want to do is take each one and say, now we want to say for each var stone in stones, we could say something if iterations is equal to 0, we're done. We return a 0. And so this way now we could say like when we give it 25, var total stone count is equal to 0. And so if we were on iteration 20, or if we're on iteration 5, we say 5 minus 0, we just get zeros back, and then we would just say it's the total stone counts plus equals get stone count of that stone with iterations minus 5. And then we return the stones that count plus the total. So this gives you the total of all the things you're doing after. And if you had 0, like you do 5 minus 5 is 0, you just immediately come out. Why is... Huh? For var x is equal to 0, x is less than iterations divided by 5. So if I gave you a 10, it would be 10 divided by 5 is 2. I don't get it. Why is it saying... That doesn't make any sense. Am I missing something here? If iterations was equal to 0, we would return 0. The total stone count is 0, then stones is just a list. And there's nothing that pops us out. Oh, because I got this here. Oh, I got that in the wrong spot. There. So when we come in the first time, we're going to say 25. So we're going to say 25 divided by 5. We need to do this 5 times. Okay. And we do our normal iteration based on the rules of getting our stone list in place. That's fine. Now we come down, so that's your initial iteration of 5. Now we come in here and we say for each one of those stones, do that one 20 times. And so for that first stone in the list of the 5, we're going to say 20 divided by 5 is 4. We need to do that 4 times. And we get its count. Actually, no. No, we don't need to do this. I don't think. I think you just do your iteration for the 5. And then you say, well, how many more am I going to do? Right? So you take whatever your iteration is. So like in our first case, we're saying, here's the seed and here's 25 iterations we want you to do on it. So we do 5, and then we come down here and we say, okay, well, 25 minus 5. So now we're going to do 20. We're going to do another 5 on just that first one of however we exploded it. And now we're going to say do it to 15 and do it to 10 and do it to 5. And then once we get down to 0, we get 0. And so we roll it all back up. And that all rolls back up for the first stone in our first iteration. And we get a total stone count. We go to the next stone and we do the 5th, 1st, 5th, 1st, 5th, 1st. Does that work with this at all? Nope. We do too many. Well, you know, I tried. I mean, I could just say iterations, like do 3 iterations. This is doing 5 iterations. This would be whatever, but it's the same difference. This is going to be a little hard to debug. I am curious, even though I'm off, even though I'm way off, let's just see how it behaves here with a bigger input. Am I actually printing out here? Number of stones, okay. And we took out the maximum. And what do we get here now? I mean, this is kind of nice that you can see we're 260,000. Yeah, so we're above a little bit. What I'm curious about is if we do part 2, this might take a little bit of time, but we're not going to run into that scenario where we explode, because you're going to have the initial 5, and then that one can have 5, 5, 5, 5, but then you roll that all up and you let that get collected, and you go to the second one. So you're kind of bounding it by just those amount of, and you can see that it doesn't slow down. It's going to take some time to get through it, but it doesn't slow down. It keeps the amount of memory rather small, for lack of a better term. The problem is with this kind of iteration, this kind of output, I don't know. Yeah, I don't know how far along it is. But I do feel like this is somewhat of the way to go in that you have to do these by chunks. You can't, you obviously can't do the whole thing at once. You got to say, here's a stone, do it after 5, then go through each of those two, do 5, take each of those 2 stones, 5. It's just I'm adding too much. This could be one of those things that it just... I mean, you could parallelize this too. This is a good problem for parallelization because you could say, okay, here's a starting one. How many iterations do you want this to be done on? And it gets that set and then says, let's create more seeds and how many iterations do we want to do on those? And you could put it apart on all of your different tasks and then have them roll back up magically. But again, the way I'm rolling this up is not correct because it's not giving us it's giving us a value that's slightly higher than what we're expecting. But by doing it with parallelization, that could also get really out of hand if we're not careful. Because if we're trying to parallelize and parallelize and parallelize, and so we're going to have all these tasks that are going to try to collide all over each other, which is not what you'd want. And the chunk size that I'm doing here is 5. Which keeps the arrays really, really small. Which is kind of nice, but it also seems like that's taking forever to get through. Because instead of, well, you're going down the same and then you roll it back up. So it's taking longer to get through each one and doing the number of iterations to get back up. I just can't tell where we're at right now. What's a better way to get an indication of how long this is going to take? I need a better indicator. Unfortunately, I don't. To debug this is good. Yeah, like I said, to debug this is going to be pretty hard. I mean, even for this one, for something as simple as this, to get 55,000 stones, that's going to be maddening to debug. I do think this is close. It's also, it has a chance of finishing. It just doesn't have it. We're going to do something with not a tab, but a number of spaces. And we slowly move it over and move it back up. And so we can see kind of where this is as it's iterating through. I'm pretty confident that just in and of itself, this works. Like if you give it a seed, it will say, okay, I'm going to do 5 iterations on it. And I'm going to split it up the way it's supposed to. That I'm comfortable with and getting us our answer. Okay. And then we look at each stone in our stones and we say, okay, well now you tell me. Oh. Well, no, we do have to read. I'm thinking it's this. Somewhere in here, this is not working out the way I want it to. I could do a test to say just do 10 iterations, because 10, if I go look at the problem again, yeah, I'd love it if it said after blinking 10 times you would have this. That would have been perfect. But to no avail. I could just do a run here and say int iterations. And that way it makes it a little bit more flexible. And so part 1 is 25 there. And then here, this is going to be run, except this is going to be 75. And we'll have to, well, I can fix that here. 25. Okay, so we've got that. Let's just put in a test here to say, let's do 10 iterations. And we don't know what it's going to be equal to. But what I want to see is, can I get some kind of indication of the behavior as we do this? I think, let's just say we did it for 5. If we did it for 5, we come through here, get our first list for that initial seed. Remember, though, we're doing this with each stone itself. Right, which is fine. And get that breakup. Then we say for each stone in stones, we would say 5 minus 5 is 0. We come through here and we would say, well, they're all 0 because you don't need to do any more iterations. And then we would say stones.count plus total stones. So the total stone count, if you did 5 iterations, you'd always get, that would be 0. Right? And so if I come back to the problem here, after 5 blanks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So after 5 blanks, we could do 5 iterations here. And I've already forgotten what I said. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we should see 13 after 5. And that fails. We see 122. Why is that? Stop. I saw my problem. I need to put 5 in here. Yeah, now that passes. So the 5 behavior works. The 5 behavior works as expected. This, though, doesn't. We get too many. So there's something about when you're doing this iteratively that you're not getting the right count for let's just kind of map this out and like screw the rules. Let's just say, did I accident? No, I didn't. Okay. Let's just say I had X, X, X. Why are you not? Why does my keyboard do this sometime? X, X. Okay. So that's your initial input. Okay. Now let's say after 5 iterations, why are you doing this? I don't. Is like my keyboard. Nope. Sometimes it gets weird like this. Not here, of course. That's fine. But you know, it's just like it's not even listening to. It's still being a jerk. Let's make it even simpler. Let's just say we have 2. And then after our iterations, we get 5. Just whatever. Okay. So now what we're going to do is we're going to take this first one And we're going to say, okay, well, what does that explode out to? So we want to do another iteration. That one we're going to say does, it's like not, okay. The second one, let's say, would give us 3. The third one gives us, let's say, 5. The fourth one gives us 2. And the fifth one gives us that many, okay? And so what we want to report is, and then this one, you wouldn't do anything. This one you wouldn't do anything. Like all these now you don't do anything because that was iteration, this is iteration 0, this is iteration 1, and iteration 2 would not do anything. They would all return 0. Okay? And so we're going to report back that this one gave us 4. So we have 4 plus, this one's going to report 3, this one's going to report 5, this one will report 2, and this one will report 7. We don't want to report like if it's the iteration minus 1, if it's the last iteration, and then we report how many stones are there. If not, so if we're on our last iteration, which would mean if iterations is 5. If iterations is equal to, my keyboard is now totally messed up. I'm gonna have to reboot. I don't know why I get into this where now everything is just messed up. If we're on 5, that means we're not gonna go forward. Like in this case. If we said we wanted to do 10 iterations and we started with this, 5 would give us that. Each of these, well, this is going to say 10. This one would give us 5, and we don't need to do any more. So we could just say here, return stones.count. Okay. Else we have to dig deeper. Right? But we can't just say here return stones.count. That's not good enough. Let's kind of take this one farther. Let's say that gave us 3. That gave us 2. That gave us 4. And we don't care what it's producing. Hit the... This one gives us, we'll say 2. Oh my God, it... Let's say 4. 4. This is unbearable. And let's say 3. This one gives us 4. I'm just picking numbers. 2, 3, 5, and 4. This one is 3 and 5. Okay. It's the ends that you want to get all the values for. The last iteration, those are the ones you want to get the values for. Let's say we got 3. We got okay, so this is our initial input. And what we really want to get to is... Stop it. Stop it. Because doing this iteration to 5 gave us this. And we're saying we want to do it for each one of these to 10, and then each one of these to another 10 or another 5 to get to 15. So it's the summation of all these end ones. That's what you really want. Otherwise, to get like... Yeah, if I'm on this row, then I need to say the total stone count is this. Because say I was here. Now I could say, well, I need to get the stone count for this iteration, which would report back 3. I need to get the stone count for this iteration. That would give me back 5. That would give back 8. And so I could report that. The one above it would get an 8 for that. That's 1, 2, 3, 4, 5. Right. So this one would say I have an 8. That's what this stone produces, is 8. And so what does that do now? It passes. That also passes. I have no idea what 10 is. That's wrong because we don't know what it is. It's 109. We said after 6, there'd be 22, 13, 22. I think it's like, it doesn't double because you can't assume that, but it feels like it's roughly that. Iterations 25. Five, and then we'll say iterations. Oh my God, I can't even type. 10, and then we'll pull this down here. So now these all 3 should pass, right? Yep. Let's go to our program. Let's run this. Do we get the same answer? 228. We do. Of course, we don't know what 75 is going to do. I really wish there was a way I could get some var stone index is equal to 0. Console.writeLine at index stone index. It's not great. At of stones that count. Because that's not going to change. So I'm kind of curious when we do program here and we do the 1, how fast does that fly by? At 0, well, I've got it. I have to increment this. At least I got something to go off of now. Let's see what this one does. Well, my computer just took off a little bit. I have the feeling this is going to give me the right answer. I just don't know how long it's going to take to get there. So what I might do is stop the stream and let this continue and then report on the next stream where we ended up. And then just let this run like over dinner time and see if it actually made any progress. You know, it would be nice Yeah, I just can't see an easy way to break through this. I think I'm also on release build. Not that that's going to make it blindingly faster, but release builds are a little bit quicker. Yeah, that was a tiny, but again, that was just visually my own. What did that actually look like? All right, so what I'm going to do is let this run and just see if this actually does finish. I'm not worried about it like overflowing memory or taking up too much, because at most with each stone, you're going to get 75 divided by 5, which is 12, 13, 15, 15 iterations. And each one's going to be roughly 20 to 30 stones. And so it's a lot of crunching. But I'll do that. And then the next stream, I'll report back. I'll do this. If I get the right answer, I'll put it in, commit this, and then maybe try to get some metrics on how long did it actually take. If it takes 30 minutes, I don't care. It's still going to be an answer. But yeah, if you really wanted to optimize for space, you could do this for every iteration. Just say like this stone produces this stone. Okay, that's an iteration. Now go through those stones. This stone produces this stone or stones. That's an iteration. Go through those, and so you're always going to have either the same stone with a different number, or you're going to get two stones. And so that way you're always going to keep just two around, so to speak. You don't even need to keep arrays. That I think might be the most efficient. That would be something fun to play with, is to see like what you're optimizing for. But for now, I'm going to let this run and see just how long this takes. Actually, let's do the poor person's version, the simple version of a var stopwatch is equal to stopwatch start new. And let's get the answer for this. Our stone count is equal to that. Stopwatch stop. Part 2 is going to be stone count. Part 2 total time is the stopwatch. Okay, so I'll let that go. If you're watching or you watch this in the future, please subscribe. I would greatly appreciate it, as I'm trying to get to 1,000 subscribers. Either way. And I plan to either maybe do a stream tonight or tomorrow morning. I am going to be on like a little 2-day vacation starting tomorrow afternoon, so I won't be streaming for a couple of days. That's why I want to do at least one more to show the result of this and maybe get another 2 or 3 parts in. But yeah, that's the schedule. And then Thursday I'll come back and keep doing more streams as I winding down my vacation. But I like this. I'm getting close. I mean, if I finish 11 here, getting day 13 part 1 done, that's the halfway point. And then we can fall off, but I'm guessing they're going to just keep getting a little bit harder and a little bit harder. I find it interesting, just the guy or the people who write this, how they determine the complexity and what's too hard and too simple, because some of this could be really overwhelming to people and some of it may not. I mean, that's a difficult challenge, I think. So in any event, I'm going to stop for now. Thank you all for watching. Take care. and I hope to see you in the future.